Hi, Chuck Huber here for the Stata YouTube channel. Today I'd like to show you how to fit a Cox proportional hazards regression model for your survival data. Let's begin by opening some example data from the Stata website by typing webuse drug tr and pressing enter. We can see that we've opened a data set that contains patient survival data from a drug trial. And if we look in the variables window, we can see that our underscore variables have previously been created using the stset command. Then if we go to the command window and type stset without any options and press enter, we can see the survival attributes of our data displayed in the results window. So let's begin by going to statistics here at the top and scroll down to survival analysis. Then we're going to go to regression models and then select Cox proportional hazards model. So let's click that, and this will open the ST-Cox dialog box. At the top of the Model tab, we see a window here that says where we can select our independent variables. I'm going to select drug. Drug is an indicator variable for which subjects received an experimental drug and which ones did not. And I'm going to begin by just leaving everything at the default and clicking Submit. And if I look in my results window, I can see that the command is simply stcox drug. Then below that, I see my stset attributes echoed here in the window, in the results window. Then I see my iteration history at the top, and then at the top of the actual output section, I can see that there are 48 subjects in my data set. There are 48 observations in my data set, so I know that I don't have multiple observations for any of the subjects. There were 31 failures in my data set, and there were a total follow-up time of 744 months. Study time was measured in months in this particular study. Next, I can see my log likelihood in my output, as well as a likelihood ratio test, which is comparing the model that includes drug to a model without drug. So I can see, based on this p-value, that this model fits better than the model without drug. Now, if I look at the output table at the bottom, I can see the hazard ratio for the variable drug, and this is showing that the hazard for those subjects who took the experimental drug is much lower than the hazard for those subjects who did not take the drug. We see the standard error along with the z-score and the p-value, so this hazard ratio is significantly different from 1, and we also see the 95% confidence interval for the hazard ratio. Now, we could include other variables in our model, so let's go back to the dialog box, and if we wanted, we could include another variable such as age. So I'm going to select age and click Submit. And now if I look at my output, the output at the top looks similar to what it did before. Now I see a hazard ratio of 1.12 for the variable age. Age is a continuous variable, so what this means is that each additional year of age at baseline is associated with approximately a 12% increase in the hazard. And again, we see the standard error for that hazard ratio, as well as the z-score and the p-value. This hazard ratio is also significantly different from 1. And then we see our 95% confidence interval for the hazard ratio for age as well. So let's go back and look at our dialog box again. There are some other options here. We're going to, for purposes of this video, we're going to ignore stratification, frailty, and time-varying covariates and those sorts of things. The one thing that we should pay attention to, even in basic survival models, is how we handle ties. There are 4 different methods. Stata supports 4 different methods for handling ties. There's the Breslow method, the Efron method, the exact marginal likelihood, and exact partial likelihood. I don't have time in a video to go through each of these and explain what they are and when and why you would use them, but it is something that you'll want to read about in your favorite survival analysis book so that you know how to use those. Okay? So anytime we fit a Cox proportional hazards model, as the name implies, we need to test or check that the proportional hazards assumption is met. So I'm going to close this dialog box, and we're going to go back to statistics, and we're going to check to see that the proportional hazards assumption is met. So I'm going to go to survival analysis, back to regression models, and then I'm going to select test proportional hazards assumption. So I'm going to click that, and this will open the eStat dialog box for Cox regression. And I'm going to select proportional hazards assumption test. And I'm simply going to click Submit, or I could have clicked OK, I suppose. And this will issue the command eStat pH tests. And here I see a global test for my model The chi-square value is 0.43, the degrees of freedom is 2, and the p-value is 0.8064. So we would not reject the null hypothesis that the hazards are in fact proportional for this model. This is good news for us. So another way we could test the proportional hazards assumption is to go back to statistics, then go to survival analysis, go back to regression models, and we could graphically assess the proportional hazards assumption. So let's click this, and this will open the STPH plot dialog box. And in this case, we're going to fit separate Cox models for each drug group. So I'm going to, for independent variables, select drug. I'm going to move this over, and since I also have age in my model, I'd like to adjust my estimates for age. So I'm going to click age here, and then I'm going to click OK. And Stata will then create a graph. Along the horizontal axis, we see the log of analysis time, and then on the vertical axis, we see the minus the natural log of survival probability. These are often called log-log plots. And what we're looking for here is that the two lines are roughly parallel. These are for the blue line is for drug group equals 0. The red line is for drug group equal to 1. And parallel is obviously in the eye of the beholder, but these look roughly parallel to me. And if we close this graph, we can see that the command that created that graph was stph plot, comma, by drug, and then we're also adjusting for age. So I hope this was helpful. Thanks for stopping by.